and 11th grade, 12th grade. And 50% in each grade. 12th grade is another name for senior. And 11th grade, I don't know what that's called, but who cares? It's 11th grade.
Junior, right?
Junior, rookie. It's not, yeah, back home we don't do these.
We don't either.
So Scotland's quite different from England. In the Scottish education system, there's only really two schools. Primary is from the babies up to 11, and then secondary is 11 to 18. So we only have two major schools. So you go to primary, and then when you leave primary, you go to secondary, and then you go to high school, university, and so on. So we have it just is different.
Interesting.
So what do you do in Sweden? How do your age and education?
We do, I think it's like 1 through 3, and then 4 through 9, and then you do whatever college is. So
okay, so when you say 4 through 9, they're not the age.
No, 4th grade through 9th grade.
Right, so you call them grades. Because America have 1st grade and 11th grade and 12th grade as well, right? So now let's move on and build the second part of it, which was to do with calculus. 20% of the senior class take calculus, right? So we'll have this as being take calc and no calc. Take calc and no calc, that's good. Right, so for %20 of the senior, so there's the senior, take calculus, and that makes 80 doesn't. And then of the other lot, it's 60 take calc and 4 doesn't. Are you comfortable about the table that I've now corrected?
Yeah, those ones I feel comfortable with.
Okay, so what we're now going to do is find the end probabilities, because they're going to help us get our answer. So a junior who takes calculus is 0.5 times 0.6, which is 0.3. A junior who doesn't take calculus is 0.2. A 0.5 times that is a 0.1, and a 0.5 times that is a 0.4. And if this works out correctly, these four add up to 1, which they do. So that's me just checking that I'm doing it right. And now I should be able to answer the question. So what is the probability that a student is a junior? Right. Suppose a calculus student. So what's the probability that you're a junior, grade 11, given that you take calculus? So I'm going to call A being a junior and B being take calculus, right? And I'm going to use a thing called Bayes' theorem. And Bayes' theorem has a number of versions, but the version I'm going to take is the one that looks like this. Have you seen that formula that looks like that? It's called Bayes' theorem.
I saw that in another video you made for a different problem.
Okay, so I'm going to use that, guys. So let's find out what each of the pieces come up to be. So what's the probability that you take calculus given you were a junior? Well, the probability that you take calculus given you were a junior is 0.6. What's the probability of A? What's the probability that you're a junior? Well, the answer to that is 0.5. And then what's the probability that you take calculus? Well, if you take calculus, you're that group of people there and that group of people there. Now, if I take this guy and this guy, do you see that there is altogether 0.4, right? 0.3 and another 0.1. So probability you take calculus is 0.4. And I
And that's
put
because
that,
you add them together, right?
yes, because I added these two together. Yes. So I'm now going to do 0.6 times 0.5, which is that guy. I'm dividing it by 0.4, and I get the answer 0.75, which is fine, but the book has 3/4 because I think they use fractions.
So when do you know when to use that one to find out if A is dependent on B versus just multiplying them together, which we've been doing?
Well, if you were being asked to find the probability of A given B, if they were independent, wouldn't the answer just be A?
So it's when they're not. So it's when they are dependent on each other.
Correct. So you use this when they are dependent. If they're independent, the answer is much easier. It's just whatever the first thing is. If they're independent, it's just the probability of being a junior. The fact that they are dependent means I have to use this Bayes theorem, and that causes a lot more work because of that.
That
But
makes a lot more sense.
Right. But before I could even do that, didn't I have to create my tree diagram?
Yeah.
And so there's only, I think, about 5 questions in that section. And I think the vast majority of them, if not all of them, are tree diagram connected.
Mm-hmm.
Mostly because there's not really a simple way of organizing a lot of interdependent information. Okay, you're a junior or a senior, but you took calculus or you didn't. You got an early ticket flight or you didn't. You actually went to the airport and caught the flight or you didn't. That was one of the other versions of that. There's very often a kind of 2 choice, and then after that 2 choices, 2 or 3 more choices. And so you have to create a tree to keep track of all the combinations of things that could happen in that storyline.
Okay. So if that comes up on the test too, when they're wanting to know the probability of that, then always just start off by making the tree to make it easier to follow along.
Don't even attempt to do it by just number crunching, because the chances are that for instance, I think it would be very hard for you to know that the bottom answer was 0.4 from the written information that's there. There's no obvious way of calculating that.